Lesson 5-4, Subtracting Exponents. Objective: I can simplify expressions with like bases in the numerator and denominator. Essential question: how do I simplify expressions with like bases? We're going to be using this subtracting exponents property, quotient of powers. So a to the nth power over a to the nth power equals a to the m minus n power. So let's look at the first example. X to the third power divided by x to the second power. We can rewrite that as x times x times x all over x times x. This one cancels out, this one cancels out, you're left with x. Now, this is what we did back in middle school. Now we're going to use the property quotient of powers. So we're going to rewrite this instead as x to the third power minus 2. So x to the 3 minus 2 power, that equals x to the first power. So that's just x. That's our simplified expression. Let's do the next one. B divided by b to the 7th power. There's no exponent there, so let's put a 1. So that equals b to the 1 minus 7 power. That's b to the negative 6th power. We don't want to have a negative exponent though, so let's move that over the bar, over the fraction. So it's going to become 1 over b to the 6th power. And that's our simplified expression. Let's look at the next one. 2a to the 5th power over 5a to the 6th power, all to the negative 3rd power. Well, first, let's simplify what's on the inside first. So we're going to rewrite it as 2 times a to the 5 minus 6 power all over 5, all raised to the negative 3rd power. So then we have 2a to the negative 1 power all over 5, all raised to the negative 3rd power. Next we will flip this a to the negative 1 power to the bottom. We'll flip it across the fraction. So we'll have 2 over 5a to the negative 3rd power. Now we're going to put a 1 next to each of these bases because the exponent's 1 if there's nothing there. And distribute the negative 3 to each of these. So then we have 2 to the negative 3rd power over 5 to the negative 3rd power, a to the negative 3rd power. All of these are negative exponents, so everything gets flipped across the fractions. So the 5 of the a's powers get set to the top and the 2 gets set to the bottom. And the exponents change signs from negative to positive. So then we have 5 to the 3rd power, a to the 3rd power, all over 2 to the 3rd power. You could also write this as standard form 125 a cubed all over 8. So this is your simplified expression. Let's look at one more example. 8x squared to the negative 1 power times 5y cubed squared all over 4x to the negative 3rd power times negative xy squared all to the negative 1 power. Now the first thing to do here, I would take away these parentheses because it's not raised to any power other than 1. The next step would be to write a 1 for each base without a visible exponent. So you can remember to distribute the bases that do not have a visible exponent. So let's do that. There's a 1, 1, 1, 1. We don't have to write a 1 right here yet. We're not distributing anything, but let's go ahead and write a 1 anyway. 1. Okay, the next step, let's go ahead and distribute each of these in. So the negative 1, the 2, and the 2. So we have 8 to the negative 1 power, because 1 times negative 1 is negative 1, times x to the negative 2 power, times 5 to the second power, times y to the 6th power, all over 4 to the first power times x to the negative 3 power times negative, so negative 1 there, times negative 1 to the second power times x to the second power times y to the second power, all raised to the negative 1 power. So let's recall that negative 1 to the second power with parentheses around the negative 1 is just 1, so it cancels out because 1 times any number is still that number. Let's flip all the negative exponents over the fraction. So that's going to go up there, that's going to go down there. So let's rewrite it after that. So we have 5 to the second power times x to the third power times y to the 6th power, all over 8 to the first power times 4 to the first power times x to the second power times x to the second power times y to the second power, all raised to the negative first power. So when we multiply the constants together, we get 25 x cubed y to the 6th over 16 x to the second y, x to the second times x to the second times y to the second, all to the negative 1 power. Now, instead of standard form, you could also write this in exponential form. So that'd be 5 squared over 2 to the 4th. And then we're going to use product of powers to combine the x's together. So 2 plus 2 would be 4. And so now we rewrite it again. And now we're going to use quotient of powers to combine the x's from the numerator denominator and the y's from the numerator denominator. So let's rewrite it with that. Okay, now we'll combine like terms. So we have 5 squared times x to the negative 1, y to the 4th, all over 2 to the 4th, all to the negative 1 power. Now let's move that x to the negative 1 to the bottom of the fraction. For our next step, we want to distribute that negative 1, our exponent on the outside, to each of the exponents on the inside. And that's usually our power of a power rule. So we have 5 to the negative 2 times y to the negative 4th all over 2 to the negative 4 times x to the negative 1. Now notice every single one of these exponents are all negative, so everything's going to flip over the fraction, over the bar. So the y is going to go in the denominator, the x is going to go in the numerator, the 5 is going to go in the denominator, and the 2 is going to go in the numerator. And that is our negative exponent rule. So our final answer would be 2 to the 4th power times x all over 5 to the 2nd power y to the 4th power. And of course, if you want to have it in standard form, you could also have 16x divided by 25 y to the 4th power. And that is your simplified expression.